All right, thanks very much. I'm Aiden Price. I'm a research associate at QUT, the Centre for Data Science in Brisbane. I'm funded by a few people. I'll acknowledge those at the end. But I'm going to talk about AusEnHealth, environmental health in general, and hopefully a bit of a spin on, rather than models, talking about how data can be used by people. So hopefully it's insightful in a kind of different way. So I'll go over, I suppose, the cause or the challenge or motivation, talk a lot about AusEnHealth, and then show you some nice visuals. Here's the first one. We want to introduce this idea of data and using data and communicating with data. And what we find, based on this lovely illustration, is that when we've got, say, one parameter, it's very easy to communicate what that parameter or variable means, especially across space, maybe a bit more difficult across time. But then as you increase the number of variables, parameters, or data, very, very quickly you lose all sort of, insight gain from it. We've got this issue, or I guess we had this issue where we thought that what we need is more data. We need more things to be able to explain, and then decision makers will have it. Well, in fact, what we're finding out is that decision makers, policy makers, people in government, even people in universities will see 30, 40, 100 different data sets and go, well, okay, how are we even supposed to start on this? How do we make an informed decision when there's so much data floating around? And so instead, what we need to do, rather than collect data, despite health data still being a huge issue in Australia, we'll move past that for now, is we say, all right, we've got the data, well, now what? And so what I'll be talking about today is the collection and transformation of that data into one place to overcome some of the boundaries and get people who need to make decisions making decisions. Here's a brief summary of the types of data we're talking about. We mostly rely on long rectangular data and take all of the context out of it. But in some instances, we've got demographics data. We've taken satellite imagery data and transformed that into the same kind of format. But there are, of course, all sorts of data nowadays that are coming in. And of course, the insights we need to make are about trend analysis, correlations, whether causal or not, are still important for decision makers, being able to predict things in future, and really inform people, right? Not just present the data and go, well, the infrastructure's there, good luck, and then move on. It's really about how we can move that into someone's hands that can make a difference with the data. So the challenge is hopefully straightforward because we're in the thick of it now in terms of extreme heat, air pollution, flooding, and all the rest in Australia. We're seeing it all over the shop, but we've got some nice gotchas there. We're in uncharted territory. We're breaking records all over the place for extreme heat. Same can be said for air pollution this time, but with risks to finance, of course, risks to health, all sorts of factors that are popping up environmentally related that we need to be acting on. And like I said, we're doing a great job of preparing data sets and creating new data infrastructure, but there's a challenge of being able to use that data to inform policy and make change. So in the Australian context, we've got all the reasons why AusEnHealth exists. The first is that there isn't a platform which brings all of the data together and adds these kind of smarts that we need to make insightful decisions with. These key groups, policymakers, health managers, and researchers, need to identify where vulnerable populations are, and they need access to tools or analysis that are existing, pre-made, that lets them move straight from question to solution. Oh, and there was more there. The third one there is the bigger problem, maybe in terms of the research infrastructure, which is where we go to a great effort or great lengths to produce insights or produce a report or paper. We collect all this information, we run all the models, and then we go, excellent, that can go in the USB, straight in the Dropbox or the OneDrive, and that's it. It gets left there, and the next person who wants to ask questions about that data has to go through the process all over again. So we're aiming with AusEnHealth to kind of resolve that issue as well. And then, of course, the big one. If a local government member wants to make decisions with their data, then they're faced with that. Well, you've got to collect 150 data sets, you've got to have your own data team, you have to have these models, or you've just got to read a report or hear some hearsay from your colleagues about the state of your local government area in Australia, for example. So we want to try and resolve or support that as well. So enter AusEnHealth. I've put the roadmap up here because it's probably the easiest thing to digest quickly. It's a research consortia funded project, so we've got supporters from all across Australia up there. Oren, who spoke earlier today, our main partner is Frontier SI, who used to be called Collaborative Spatial CRC. Their main effort or remit, I suppose, is to bring government, researchers, all those decision makers, stakeholders together for projects like this. And they've done a tremendous job in the case of AusEnHealth. And then, of course, EPA Victoria, turn other government agencies who have data or want to use data, but are asking questions about how to do that because, again, there's so much of it. So we went through a process. I won't go through every step here, but maybe just a couple, mainly the use case workshop, the visualization review, and trying to figure out what environmental health data was the most important, what we could summarize quickly, what we could even access in Australia, even with the skills that we have as a data science team, and then how we can get the most bang for our buck in terms of presentation to end users. So we ran a data audit, had some use case workshops, and very quickly identified that there were three main ones. There's extreme heat or extreme climates, because cold is included in that, air pollution, and water quality. The data audit, in that next step, identified very quickly that water quality isn't something that we could capture in the project because the infrastructure doesn't exist on a national scale. And that's really something we're aiming for with AusEnHealth as well. And then the rest is, okay, well, once we've got the data, how do we put that together? How do we add the smarts to it? And how do we present that to end users? In terms of adding smarts, I've interrupted my logo there, but that's AusEnHealth, of course. What we want to do is be able to pull all the data together and make it available in its own space. So a lot of the issues people have is they say, okay, well, if you want, I don't know, some census level data that's not available directly publicly, you've just got to reach out to the custodian and I'll give it to you. If you want this health data, I don't know, if you want school locations, you've got to reach out to this data custodian and that data custodian and this person and that person and go through a 2-week process for this, and all of a sudden 6 months or a year of your time has been used collating the data in the first instance. So AusEnHealth aims to first remove or reduce that problem by housing a lot of the data that's been collected, noting that it is publicly available and saying where to go and get it if you want to get it from the source, but also displaying it for access, I guess, locally for users to use or download. Harmonize it, filling in missing entries through imputation where we can, but other cases where we can't, we just claim, we don't have efficient ways or good ways to do this, so we've left them as NAs, etc., missing data. And then the second class is the smarts. So these are new data assets or transformed data assets, a derived variable that might take hospital locations and instead convert that to a population density-based measure, so that instead of having to look on a map for where your hospitals are, you can just look at a parameter spatially and see, okay, this region has more hospitals per population, etc. Very easy to interpret. Then we move through to indicators, which are transformations of one or more data for the same kind of thing, but have a health or risk, focus. And we'll look at that in a bit more detail. And then a vulnerability index, where we say, okay, to get 1 or 2 parameters, how do we take 30, 50, or 100 parameters and summarize those effectively? And we'll talk about that a bit too. Okay, so in terms of what we want to achieve here, hopefully it's nice and clear that we've got this existing, decision-making cycle, and our aim is to reduce that as effectively as we can to something more bite-sized for a decision maker. Get rid of the data access and data collection portion, and also get rid of as much of the data processing portion as well, leaving a decision maker to ask a question, go to a platform like AusEnHealth, see the solution, then ask questions about it, make decisions about it, and formulate the new questions. Okay, so this is an example of one of our indicators. Hopefully it's visible from the back, but it's pretty light in terms of what we're doing here. All we're taking as an example is our raw data, which is maximum and minimum daily temperature at a gridded level across Australia, each day for 20 years. And again, I've got a dot point here that if we presented that to an end user as is and said, all right, we know that you're from this LGA, but you'll figure it out, you're smart enough, that's 14,600 data sets without processing. And it's still at the gridded resolution, which means they've got to figure out that step too. Well, what we do is instead we do some derived data first, create average daily temperature to halve that set of data. We create some aggregate data, so transforming it from gridded resolutions to more aggregate resolutions. In Australia, these are SA2, SA3, SA4, etc. LGA in there as well. Then move them from daily to higher timescale aggregates by instead counting specific threshold exceedances. So in our case, we've got a number of days exceeding the 85th percentile and the 95th percentile. And we flag those as, I guess, heat risk and high heat risk. And so instead of looking at 14,000 different data sets, you might pick 2019 for your LGA or SA2 or whatever it might be. And you see, oh, okay, my region's over the 85th percentile 16 days that year. Right? So a very, very streamlined and simplified process to get from raw data to something insightful and usable. Okay, I've been told I've got 1 minute left, so we're going to go into speed mode. So next we're looking at indices. And this works in a similar way, but there are a lot more steps. So we might apply some kind of framework, break them up into themes, and then simplify those themes. And I've got some methods that are coming up, but we're going to zoom right past them. The end result there is that we get one value for vulnerability. We break that down into some notation, which we'll skip by. We've got an approach to try and make that notation better. And this gives us some lovely visuals as we progress through the set of annual yearly data that we prepared for the presentation. We use it in a platform. So we put it all together. We present it in strategic ways to make sure that an end user can get the most insights out of it. We show some examples of that here, where we're displaying the data, displaying different charts, and of course displaying the cold as a very quick reference point. This is behind a closed door at the moment because the platform's not publicly available. So instead I made a public Shiny application. This takes the data that exists, plots it on a choropleth map, and we also have other features like region breakdowns, which is a key component when you're looking at end user, I guess, use. It's one thing to see vulnerability. It's another thing to be able to dive in and say, what does that vulnerability actually represent? And then, of course, region comparisons. Maybe you want to know, okay, the heat vulnerability index is the same in these two locations, but what does that actually mean for the underlying parameters? Okay, and of course, the acknowledgements. I'm funded by a few organizations, Oren's included in that, and a special thanks to HEAL in particular for funding my trip here with a HEAL Travel Award. Thanks, guys. Yep.
I can speak loud, that's it. Oh, do you need that for recording? Recording, okay. All right. Okay, thank you so much for the presentation. Just a quick one. This is all based on historical data, right? So what you're presenting is a picture that regarding any of sort of the indicators of vulnerability, it's based on the past and perhaps the present. Is there any possibility that you're going to think about future models, like incorporating not only GCMs, I mean global climate models or global models, but also regional models, because that will help a lot, particularly with the stakeholders, to engage and start a conversation to see what are possible adaptation mitigation strategies they can implement, so they don't look only at historical data, but they want to see what they are in terms of sort of different scenarios and timeframes in future. But just to know if this is going to be happening or not within this platform, which is already running.
Yeah, so I'll very briefly show maybe this slide. For people who can see it, there are these 6 panels along the bottom which say, here are our demonstrators, here are the ways that we're choosing to communicate all the information we've collected to you. There's some in there that offer just the data in different ways. Others are looking at forecasted climate, for example, using IPCC forecasts. And others are looking at enabling user uploads and public data sources so that people can draw other information into the platform. But of course, for brevity, and I even went over, I wanted to show only one of those, which was the heat risk assessment demonstrator. So yes, I guess is the short answer to the question. There's definite capacity to bring in other information, modeled information, etc. The big thing, and that's the thing I started with, is that we don't want to overwhelm a user. So that's a key part of pulling in models, is we've got to pull in the right ones that we can communicate, in the right ways. Thanks.
No? Thank you very much. So we move on to our last presenter, Saudi Arabia.